So, good morning to all participants. Today's very interesting and informative lecture is by Dr. Shaukat Rasool on the topic AI and IoT based smart supply chain management for horticultural produce. Dr. Shaukat Rasool, he is working as assistant professor in the Farm Machinery and Power Engineering, College of Agriculture Engineering, and presently he is heading the Center for Artificial Intelligence and Machine Learning Center, and he has almost about 8+ year experiences in this area, and you will be greatly benefiting from this lecture how we can use AI and all these latest AI machine learning tools for your different supply chain areas. So I hand over to Dr. Shaukat for continuation of this lecture.
Thank you very much, Professor Rakesh Mohan Shukla sir, for inviting me in this training program to deliver a lecture. First of all, I congratulate you that you have been doing a great work, and by providing participants know-how about this training program. I believe this training program is very much relevant and very much important as far as the horticulture sector industry is concerned. As we talk about Jammu and Kashmir, it's a horticulture based industry, with over 10,000 crore industry. Much of the GDP is dependent on the horticulture. And when we talk about, increasing our productivity, and it cannot be done, alone. It has to be, augmented with the technology that you are talking about, smart packaging and supply chain management. So when we talk about infusement of technology in the area of horticulture, so we have seen a boon in as far as the development of these high density apple orchards is concerned. So production is increasing at a very high pace, and establishment of high density apple orchards is also taking place. But at the same time, the challenge remains how we manage the produce that comes out of that out of our orchards. Recently, you have seen that small problem in our highway resulted in a huge loss to our farmers. So as far as the supply chain management and packaging is concerned, it is having it's a very important, and we need to infuse new technology into this area so that we will be able to save our produce and make it available to the consumers in a fresh manner. Okay. Health issues are also increasing at a very faster pace. The diseases that are linked to the food products of the people, the cancer increasing at a very faster pace, particularly in J&K, in other parts of the country also. So the packaging as well as supply chain management of all the food products, and particularly horticulture produce, which is an perishable, fresh, is need of an hour. Now talking about these technologies, when we talk about artificial intelligence and IoT in supply chain management, so I'll be talking about that. But first of all, let me set the context and take you through the steps wherever agriculture has been, and at what stage we have been reached, and what are the technologies which drive this system. So this is a general overview of various revolutions that took place in an agriculture. The first of all, we have agriculture 1.0. Okay, agriculture 1.0. So in that, it was a traditional agriculture, particularly dominated by so this has been dominated by manpower. Manually, people were doing the operations or through animal force. So this was a traditional agriculture. Now with the invention of an engines, we started using machines in our farms also. So agriculture 2.0 is basically an agriculture mechanization. It's a machine focused. Now the job of the manually has been replaced by the machines. Similarly, you have agriculture 3.0. The machines that we're using, we have automated these machines. We have made these machines automatic. They are now doing jobs on their own, through automatic technologies. So they were, based on computer programs, but they were unsustainable. They were not resilient, and they were having a cybersecurity issues. But automation was there. I'll give you one example that we used to, have a combine. We used to have harvesters. Okay, we used to have maybe vertical harvesters, reapers, and other things. Then we came out with combine harvester. So all these operations were automated, and in one machine we used to do all the operations. Then there came agriculture 4.0. It is mainly driven by the technologies that we are going to discuss today. It is artificial intelligence, it is Internet of Things, it is maybe blockchain also, and it has improved the level of automation. Earlier there was some level of automation, then now there is a high level of automation in that. So the systems are completely automated, and we in this agriculture 4.0 we started talking about sustainability also. Okay, we don't want to invest our resources haphazardly, uselessly. We want to preserve our resources or preserve our environment also. So in that we used to talk about sustainable agriculture. But again, there were issues with the cybersecurity, the data reliance. That was the problem. Nowadays we are talking about agriculture 5.0. All these systems, the independent systems that we have, these independent systems are now interlinked to each other. For example, if you have 10 tractors, they are autonomous tractors. You have drones, you have robots. It's not that these robots, drones, and tractors are operating individually. They are talking to each other. You have sensors all over the field. These sensors are talking to each other. They are in a one platform. And the readings from one system goes to the next system. And the readings of one system inspires the activity of the second system, that they are interlinked to each other. They are on one platform. So this is basically, and these are human focused also. So this is basically agriculture 5.0. And in that agriculture 5.0 we do talk about sustainability, we talk about resilience, and we do talk about societal well-being also. Okay? Now the question is, so these are the 5 revolutions that we talked about. So where we are and where are the developed world. So this is where we are. We are still lagging behind between agriculture 2.0, mechanization, and some sort of automation, whereas developed world has reached beyond agriculture 4.0, and then now they are talking about agriculture 5.0. In the coming slides I will take you through how these technologies are impacting the agriculture sector, and what are the backbone, what are the principles behind these technologies. Now there's a new era of farming, and this we specify by different names. So one name is smart agriculture. We call it a smart agriculture because this smart word has been used most widely. It started all from the smartphones, and then we are saying that everything is smart. We say smart machines, smartphones, smart devices, all. That's why we called it a smart agriculture. Otherwise the proper term for that is a precision agriculture. What is precision agriculture? It is basically applying right amount of inputs at a right time and a right place. Okay? It's about inputs, but it can be taking a right decision at a right time and a right place. Okay? It is applicable all over. It's not applicable to on-farm activities. It's also applicable to off-farm activities also. So we also call it a site-specific management. You go to that particular site and you observe that site and then take a decision based on the site. There should be both, we have both spatial variability as well as temporal variability. You take care of the both variabilities. Spatial, that means the variability occurring from one place to another place, and temporal, this variability is occurring from one time to the another time. So when you take this into consideration, what will happen? The first of all, the first result outcome of that, these precision smart agriculture or site specific management is that you are leading towards an increased efficiency. Okay? Your efficiency is getting increased. So the amount of inputs that you apply and the output that you get, the output is more and the input is less. That's why we called it, it can be resource use efficiency, it can be any efficiency. Then the second thing that you are getting is that you are going towards a sustainable practices. You are not, dishonest towards your environment also. You are taking care of the environment also. You are not going for haphazard application. You are not going for wastage, and you are not impacting the environment, and you are not impacting the human health. And the third one, obviously, there is there is an enhanced yield. Okay, there is an enhanced yield from the perspective of on-farm activities, and there is a reduced wastage when we talk about off-farm activities. So we also call it a digital agriculture, smart agriculture, precision agriculture, and digital agriculture, because it is driven by these digital devices, digital forces, digital technologies. So what are the 4 steps of this digital agriculture? So very simple, I am saying this, there are 4 components of this digital agriculture. The first component is what? You have to monitor the things. When you monitor the parameters, then only you will be able to take the right decisions. The first is when you, for example, you are ill, you are not well. You go to doctor, you tell him the symptoms, and then he will prescribe you some tests so that he will analyze your body. He will prescribe some scans so that he or she will analyze your body. So that's what we call it monitoring. You will monitor it. Okay? So monitoring can be done with the help of different devices. Okay? You have different devices available to you, and then you can monitor the things. Then you are going to now when we talk about agriculture setup, it's not only possible that you will go for monitoring of each and every step. It's not possible that you will monitor at each and every time. So what you will do is that you will go for the prediction also. So you have some initial conditions, boundary conditions. So this is there, and then you will go for the prediction also. The predictions can be done with the help of different models. It can be empirical model, statistical models. It can be mathematical models, or it can be models driven by the technologies like artificial intelligence, machine learning, and the big data analytics. And when the prediction has been done, what is the next step? Now we have to decide what to do. What should be the temperature of that atmosphere? What should be the humidity of that? What should be the level of gases in that particular environment? We have to decide. When we have decided, when the output parameters have been, we have taken out the output parameters. These are the desirable, suitable parameters in which our conditions will be best for our produce. Then we have to automate this operation. There should be some automatic devices within the system which will change the temperature itself, which will change the humidity of the environment, which will change the gaseous concentration of the environment. So this can be done. We have to use sensors. We have to use sensors and IoT platforms. We have to use data platform. We have to use AI ML analytics. For example, in prediction, then you have to use maybe you can use unmanned aerial vehicles, robotics, automation, and decision support system. So these are this is the basic crux of digital agriculture that we are going to talk about. Now, I just want to give you a brief glimpse of how our, smart farm will look like. We'll call it a farm of the future. So it's not only restricted to, production environment. You can see there in the center, you have a crop, which is being grown in that area. But at the same time, you could see that different devices are around. You can see the real-time crop monitoring is being taking place, and there are some drones which go for precision pesticide application. Then there are some ground vehicles, harvesters are there. They are harvesting the crop. They are fitted with some GPS sensors. okay? And then, you have, other sensors like variable rate applicators, which is, managing your farms. Then you have your livestock also. So livestock, each livestock is, fitted with a GPS. You are tracking your livestock also. Then you have, some people which are not in the farm, which are outside the farm, but they are checking some analytics, and on the basis of that analytics they are just monitoring the things. And then you can see one control station is there, outside the farm. One control station is there, while all the data from all these devices is going, and this when the analytics is being done, then this information goes back to the devices which are on the farm, maybe tractors, maybe sprayers, maybe variable rate applicators, and this analytics also goes to the user. So user can see how my farm is being managed. So the question is, there are different devices, but these different devices are not working independently. They are dependent on each other. The decision making center, the control station, are taking data from different devices and then analyzing it and then giving back it to the devices so that they can take care of the farm. So that is why your 4 components of digital agriculture are being executed. One was monitoring, the second was prediction, the third one was decision making, and the fourth one was automation. So this is how our farms of the future will look like. Now talking about when we talk about this smart supply chain management, okay, and when we talk about horticulture crops in general, we know horticultural produce is highly perishable. We have to it's not, even the grains also need proper storage environment and all other produce. But as far as the horticulture crops, when you harvest it, then you have to make sure as soon as possible this produce should reach to the consumer, it should get consumed, because it's highly perishable. As far as Kashmir Valley is concerned, although it's a very apples are high value crops, but our economy depends on that. It's a perishable, apples, vegetables. Our high value crops are all perishable, okay? So losses occur mainly after harvest. So you harvest it, losses occur. So not only after harvest, when you transport it to some place, losses occur during that also. Now, how to reduce these losses? We have to infuse the technology so that we are able to reduce the losses that are occurring at each and every step. So this is overall, this slide is a little bit clumsy, but this is giving you a whole concept, what is happening. So if we start from pre-harvest, so crop is in the field, and now you have harvested it. Once you harvest it, what will you do next? What is your next step? The next step that farmers usually should do is that they should go for a pre-cooling of this produce. Little bit pre-cooling, and the research has shown that if you go for a little bit pre-cooling of the produce, it can increase the shelf life of that product. Although it's perishable, but it has capacity to increase the shelf life of the product. Once that pre-cooling has occurred, then the next step is that you have to go for the packaging. The packaging should be as efficient as possible. So various types of packaging material are there. They may be biodegradable, they may be but the whole concept is that we have to increase the shelf life. So packaging should be such that it should not physically damage our crop also, and it should protect it from from other factors also. So that is packaging. The next step is, when it has been packaged, now it has to we have to transport it to particular mandis from which we go to the consumers. So I will before I elaborate it, many lectures have been delivered so far, but I will just give you a brief intro about what is going on during storage and packaging, transportation. So what is the best way of improving the shelf life of the product? Easiest and best way of improving the particularly perishable products. What is that? For example, apples are there. You want to increase the shelf life of the product. What is the first? simply cold storage. You reduce the temperature. And research has shown that reduction in temperature can increase the shelf life 2 to 3 times per 10 degree reduction in the temperature. So you'll reduce the temperature by 10 degree, shelf life gets increased 2 to 3 times. It's one of the, that's why pre-cooling, we took it, we did the pre-cooling. This is one method. The second method is that you can, when you have stored your perishable product and when you have packaged your perishable product, one more, the way is that you can alter the gas composition within the environment to slow down the metabolic activities of these produce. And in that, what you are doing is you are basically reducing oxygen and increasing the carbon dioxide. This is the simplest thing. And this process we call either modified atmospheric storage or controlled atmospheric storage. But at the same time, when metabolic activities do occur within that produce, and some ethylene gases are also produced. So what you do is that you may put up some ethylene gas absorbers also, so that you will remove the ethylene gas from the environment. So you can go for dynamically controlled atmospheric storage also. Okay? And this was about cold storage, then it was about modified or controlled atmospheric storage. What is the third thing that can be done? Any other method? That may come to your mind. Any other method? Active packaging.
Where you modify the environment.
No, it has been modified. It will come under modified or controlled atmosphere storage. The third thing is that you can go for coating of the fruit also. So when you go for coating of the fruit, basically what you are doing is you are tailoring the gas exchange between the fruit and the atmosphere. You are stopping it. Okay? In that way also this shelf life of the produce can be improved. So that's okay, we can do it, but that is limited when that produce is at a single place. When it is moving from one place to another place, when you are shifting, for example, now we have trains in Kashmir here. So you take it from your produce in trucks, then you reach to the railway station, then you have to shift it, to the railway that cabins. Okay, so you are shifting it. You are not restricted to a single climate. And when from trains it will go again to the trucks, then it will go to the mandis, and from mandis to. So at each and every, we call it a transcontinental transport system. So when this occurs, so it's very difficult, to have the same atmospheric conditions. We cannot keep it cold everywhere. And nobody can be reliable what these trucks, whether they are really cold store trucks, modified atmosphere trucks or not. So we cannot control it. So a lot of challenges are there. That's why it's very difficult to control this. So we'll discuss how to do it and how to achieve reliable storage systems, transport systems. But this is about transport and storage system. When you do transport and storage, at that time, it's very important that we should monitor the things each and every step. We should not monitor only in storage, but we should monitor during that intercontinental transport also, transcontinental transport also. For example, you are taking what was the temperature at the railway station when it was shifting. Okay? What was the temperature in that truck? What was the temperature in that railway bogie cabin? So because see, temperature of the Kashmir Valley at the time of harvest, it was maybe 20 degree. Now you took it to Jammu, it is 30 degree. Now you took it to maybe some southern states, it's around 50 degree. So this is also changing. You should monitor temperature, humidity, and many other conditions at each and every step. So that's why the monitoring and sensing is given there. Then after that, it goes to for retail, and ultimately it goes to the consumer. It goes to the consumer. And when it goes to the consumer, it will not go to we have unloaded it and directly it will go to the consumer. First of all, it will go to maybe some shop. It will go to some that vendor also, local vendor. So it also depends how that local vendor. I believe that if we are able to secure our produce up to that level, but again it gets perished at that vendor level also. So this is overall the steps that we have. This is overall steps that our produce goes, and we have to see where we are failing and what steps we should take at a particular point. You are all aware of this, this post-harvest loss, how it occurs, moisture loss occurs, and then many things in between. I'll not go into detail of that. Now I will try to go to, and this storage that I was talking about, this is the weakest link. Okay? This is the weakest link because we are not able to, produce the same environment in that storage. Now I will go to the technology part. Okay? From conventional storage from conventional supply chain to smart supply chain. In a traditional system, what you used to do, okay, you used to inspect manually what is happening, whether my fruit is getting deteriorated, whether it is fresh, it's not fresh. So it was all manual. So what if you place some sensors that are smart, that are IoT based, and you are getting real-time updates, real-time data, and it's not only monitoring, then you are going to the second step also. What was the second step? Second step was prediction. You are going for predictive decisions also. Okay, you are going to check, so this is the temperature, humidity, and these are the gas levels. So how long my produce will last? Okay? This is, the predictive decisions will come out of it. So at this point, at this stage, we are after 20 minutes of this lecture, after 25 minutes of this lecture, now we are pretty much sure, no, monitoring is very important. And that too, real-time monitoring, that's very important. So then we'll see how it can be, safeguarded. I'll go to these slides, but before this, I'll go to this slide. I'll try to explain you, because we are going to explain two things, artificial intelligence and IoT. So let's first of all break down what this IoT means. By definition, it means Internet of Things. So let me give you an example. If I am going to measure any condition in any environment, I may take a physical sensor in my hand, go to that particular environment and measure the parameter that I am going to, that I am going to measure, and then there may be some, there may be some display system in that sensor which will indicate me the value of that parameter. For example, temperature, humidity, gas, jo bhi. And then I can note it down. Okay? Simply I can note it down. This is the one method. But you can see the ways that we have, seen this. It is at a farm level. Then it goes to the storage level. Then it goes to transport level. Though a person at every step cannot go inside and take that sensor along with it and take the readings. What we want is that sensor should automatically be placed inside that environment, and it should automatically give some readings to us. Okay? When it gives readings, the readings will be stored at some point. That we used to say it's a control station. Okay? Control station पे जब readings आती है, then we fed these readings to some model, predictive model, and get some insights about it. And then this information should go back to the storage system where some sort of actuator will activate and will change the condition. For example, if sensor will check temperature is increasing, it will go to predictive analysis, see what is the optimum temperature, and then it will go to the cold mechanism, जो भी उसका होगा, so that it will bring down the temperature. So basically what is happening is that there are many things. First is sensor, that is one thing. Then there is a control station, that is one thing. They are talking to each other. They are independently talking to each other, and then control stations again talking to actuators. So they talk to each other. They talk to each other in a language. That language is what? That is internet. These things talk to each other in a language that is through an internet. That's why we call it Internet of Things. These are all things. Sensors, control station, actuators, they are things. And when they talk to each other in a language, we call it an Internet of Things. Okay? So it refers to the intelligently connected devices, systems to leverage data gathered by embedded sensors and actuators in machine and other physical objects. About who coined this term, it is given here, you can read it. And then, when we talk about communication between these things, it can be device to device. For example, sensor is one device, one thing, and then our control station, our computer system, that is one thing. It can be from device to device. The other thing can be device to cloud. So you are not giving information directly to the device. You are taking this information, feeding it to the cloud. What is actually a cloud? Cloud is a data center where you store the data, and from where you can fetch that data anytime. जैसे आपका Google storage है, Facebook का data है, वो सारा कहाँ store है? वो cloud पे store है. And the third thing is you can have device to gateway. You are not feeding your data directly to the cloud, but first of all you are taking it to one secure place. That secure place is what? Gateway. And then you are feeding this from the gateway, lot of data you are feeding to the cloud. So that is device to gateway backend data sharing, we call it. So what is the need of IoT? Particularly though you have completely understood, say if we talk about supply chain management, if we talk about storage, how important the Internet of Things is in this line. Similarly, in other farm activities, Internet of Things is very essential. Some of these things are given here. You can read it. I'll share the PPT later, and then you will have a good idea why the Internet of Things is needed. So, benefits of IoT, it is basically technology which drives our agriculture 4.0. Okay? Why we say that our system should be completely automatic. Okay? It should not be only rule-based automatic. It should be I will discuss one more technology with you. I am just giving a hint about that. That technology is known as a digital twin. I'll discuss that, and then in that you will say how important this Internet of Thing is. And this Internet of Things is basically a driving force, along with the AI, is the driving force for Industrial 4.0. That level of automation could never have been possible if there was no if there was no technology like Internet of Things. And it's not only agriculture why this Internet of Thing is helping us. It's all other sectors also. It's healthcare, it's transportation. I am just giving you some examples. 1 million, the number of lives in health that can be saved in sub-Saharan Africa with the help of Internet of Things. Similarly, $400 billion dollars, that's the amount that can be saved in annual healthcare if we use Internet of Things. And it's a 40 million people in developing countries that can be fed each year due to these type of technology, because we can reduce the waste. Similarly, several other examples are there by which Internet of Things can have a huge impact on the benefit of the society. So what are the technologies that actually enable Internet of Things? The first and foremost is the availability of cheap sensors. In recent years, we have seen that when I was in I along with Professor Shukla sir was also there. We were in IIT back in 2012 to 2017. So these years we were there together. We could see that when we are having some sensors in our lab, one sensor costs around 3 lakh rupees, 4 lakh rupees, 5 lakh rupees. Huge cost was there. We had one company that's known as National Instruments. They used to make load cells and other sensors. They were huge, of a huge cost. And then there were one more. We used to call it a data acquisition system. DAS, data acquisition system, where you connect all these sensors and get the readings. जो भी हम कोई experiment वहाँ करते थे, automatic ही होता था, but there was a huge cost of the sensors. Now we have seen this cost of the sensors has reduced drastically. It's because of recent developments in electronics and in computational methods also. ठीक है? अभी आप देखिए आपके computers में you don't only have CPUs in your computer, you have GPUs also in your computer. Earlier there were some graphic cards and then you have graphical processing units. Anyways, the cost has reduced a lot. That is first thing. And the second most important thing is that the bandwidth, the internet that we call, it's 40 times cheaper. पहले जो हमारा इंटरनेट रहता था ना, जस्ट रिसेंटली तो हम क्या करते थे, डेटा ऑन करते थे फिर ऑफ करके रहते थे, हमारा डेटा वेस्ट नहीं होना चाहिए. एवरीबडी इन दिस रूम, एवरीबडी आउटसाइड, all of the people have availability of the data, and that too 40% cheaper, very cheap. जब से वो the Jio introduced the fiber also, that they also it becomes very cheaper. And then when we have IoT devices, when we have sensors, then there was an availability of the data also, big data. Now we can collect the data at any point, and then you can do anything with the data. So these are the three top things: sensors, bandwidth, and then big data. And at the same time, cheap bandwidth, with it there comes a coverage also. If you go to any part of the world, any part of India, at least you will find that you have wireless coverage there. Availability of the internet is there, right? Most of the places, at least the places that I have gone, I have found that even I went to the hilly places of Ladakh, Kargil, so internet was available. And one more thing is that smartphones is also available on each and every hand, and then cheap processing and smarter chips. Okay? So these are also available. These are the basically technologies which drive Internet of Things. So what are the elements of Internet of Things? Just focus on this slide. Number one is your what? Some sensor to understand the device and environment around it. So sensor should be there, which will understand the environment around it. Then whatever parameters you are going to measure, you can do it. The second is device, and this device should be programmable system. You should be able to program it. कोई ऐसा device होता है ना जिसको आप program नहीं कर सकते, but sensor should be there, and then some programmable device should be there. This is second. The third one is program itself. What is program? It's a set of instructions which controls any system. A set of instructions. You can write it, program, जो भी आपका C program, C++ program, Python program, जो भी program आपका. So third thing is a program that controls the device and works with sensors and coordinator server to talk with the remote server. And fourth one is a remote server. When you have a sensor and then you have a device also, and then you have program also, then there should be a remote server where you actually store this data. ठीक है, स्टोर तो करना है ना कहीं. सर्वर जिसको हम क्लाउड भी बोलेंगे आफ्टर सम टाइम, where you store that data so that you can analyze that data and do some predictions or analysis or whatever. There are 3 layers in IoT. How many layers? 3 layers. First one is perception layer, जो bottom में दिखाया गया है. Perception layer, physical layer. Physical means वहाँ to which devices होंगे. For example, your sensors is one of the device there. Sensors में आप देख सकते हैं GPS, है ना. आपकी जो स्टोरेज की गाड़ी है वो कहाँ से गई, अभी वो कहाँ है, कितने देर वो चली, तो GPS will be needed. And then temperature sensor, ठीक है, humidity sensor, a moisture sensor, accelerometer to detect the speed and other things, maybe pH also, maybe pressure, maybe illumination, some other devices also. Then you may have actuator also. एक तो हो गया sensor जो sense करे, दूसरा होता है actuator which will take some action. I will give one example. For example, automatic irrigation system की बात करें, हमारा field में कुछ sensors लगे हुए हैं, ठीक है, and these sensors are measuring temperature, humidity as well as moisture level of the field. And then the moisture level goes down, and from these other environmental sensors we came to know that there is no possibility of the rain in next 24 hours, and temperature has gone down to below 40%. Now what we need to do is that we need to put some moisture in the field so that moisture goes up to 80% level. So what you do is that you instruct the actuator. What is actuator here? Sensor is measuring the temperature. Actuator means which does the actual action, which can improve the moisture level of the field. Maybe some water pump. You can on that water pump. That water pump is actually an actuator which will take this water level to the optimum value. And then you have controllers also. You have RFIDs, many things. So this is a perception layer, while there will be devices, physical layer, while there will be sensors and actuators, as given here in that, in bottom layer. The second is that the sensors are now talking to the other devices. So they need a network so that they can, talk to, other devices. So, yeah, network can be, it can be Wi-Fi. It's one of the network, It can be Bluetooth. Bluetooth is also a network. It can be mobile communication, 2G, 3G, 4G, even 5G also. It can be Zigbee. It's also one of the communication protocols. Okay? It can be LoRa also. LoRa is long range wide area network. It's a low power network. Each one of these network has its own advantage and disadvantage. For example, Wi-Fi. The advantage is that you can transfer a high bytes of data.
Some ranges.
Yeah, exactly. In Wi-Fi, you can transfer high bytes of data, but the range is limited. Range can be maybe few meters. Similarly, Bluetooth, also you can transfer high volumes of data, but the range is limited. As far as mobile communication, 2G, 3G, 4G is concerned, it has both range. आपने देखा मोबाइल टावर किलोमीटर्स में उसका 10 किलोमीटर 15 किलोमीटर जो भी उसका रेंज होता है, you can transfer data in that range. But more power is required for that. Three things are there. One is data transferability, कितनी GBs का data वो transfer कर सकता है. Second is range, and third one is how much power it consumes. ठीक है? As far as the LoRaWAN is concerned, it's a low power, long range, wide area network. You can have a network of around 10 kilometers, maybe 15-20 kilometers also, and it's a long range. That's why it's called long range. It's a low power also, but at the same time, but it cannot transfer high volumes of the data, limited volumes of data. And the third layer, the network layer, is the middle layer that is shown here. The third layer, you have application layer. You do monitoring, you do management, you do control, application from point of view. You have unmanned machinery, maybe drones and other things, or your storage system. You have a system which will, regulate the, temperature of the environment. So this is basically, layers of that. Now, before I go to the other network, how it works, I will request Saqib to show us some devices so that, we will be familiar with what these devices are. क्या है पहले? पहले ऑर्डिनो है आपके पास? हाँ, ऑर्डिनो भी निकालो आप, रास्पबेरी पाई and Jetson Nano. Okay, so I'll start with a basic. Now the controller. There were three things, if you can see here in this slide. Some sensor. You have some sensor with you? Okay. Gas sensor. Anything else? Temperature, humidity, something? This sensor, possibly it measures carbon dioxide. It's a sensor, gas sensor. And then you have a load cell, which can measure the weight of any object. Maybe I have just presented here a small, sensors which are, prototype level sensors. So this is temperature and humidity sensor. This is a light sensor, maybe. ठीक है? तो different types of sensors हमारे पास है. This is the first layer. This is GPS. ठीक है? This is GPS. तो ये आपका GPS है. फिर ये आपका this is ultrasonic sensor. ठीक है? This is ultrasonic sensor. So you have all these sensors. So this comes in the first layer, the physical layer. And then we need to connect these sensors, all of these sensors, to some device, programmable device. The first programmable device that we have you seen this? This is Arduino. It's a microcontroller, okay, which has a limited memory, very small. It's a very cheap, costs less than 500 rupees. Very cheap sensor. So you can connect all of these devices with these programmable device. For example, मैंने यहाँ ये जो है ये डिवाइस मैंने कनेक्ट किया, या आपके पास GPS है, मैंने यहाँ GPS कनेक्ट किया, ठीक है, मैंने GPS कनेक्ट किया सारी डिवाइसेस. नाउ दिस डिवाइस कैन बी प्रोग्राम्ड. यहाँ एक इसका लीड लगता है और उस लीड को हमें कनेक्ट कर सकता हूँ किसके साथ, लैपटॉप के साथ. एंड देयर इज अ वन इंटरफेस, ऑर्डिनो का अपना सी प्रोग्रामिंग का इंटरफेस है, वहाँ आप इसको प्रोग्राम कर सकते हो कि भाई इसमें जो इनपुट डेटा आ रहा है उसको एक्सट्रैक्ट कर सकते हो, इनपुट डेटा क्या आ रहा है क्या नहीं आ रहा है. सो देन यू कैन मेक इट अ कंप्लीट. यहाँ आप एक डिस्प्ले सिस्टम भी लगा सकते हो, है हमारे पास डिस्प्ले, इसमें जैसे ये डिस्प्ले एक सिस्टम लगा हुआ है. And then the readings from these sensors can be displayed in this display system. ठीक है, it's a very simple thing. So this is our first device, but this device is it can only do it can take the reading from the sensor and display these readings. It cannot do anything else. Now if I want to do more, not only taking readings from the devices and controlling some other actuators, if I want to do some analytics also, then for that it's a computer. Okay, it's a computer which is fitted in my palm. This computer is a single board computer, SBC, and the name of this is Raspberry Pi. ठीक है, इसमें जैसा आपका नॉर्मल ये कंप्यूटर है वैसे ये कंप्यूटर भी है, एंड फिट्स इन माय palm, इतना स्मॉल है. So I can connect all these sensors with it. I can do some analytics also, some predictions also. I can run some prediction model on this device also, and then I can make my system more automatic. So this is our what? This is Raspberry Pi.
Connection is made through this.
जैसे इसमें सर कुछ pins है, pinouts हैं.
अच्छा.
You have a pinouts here. You have pinouts here also. So there are digital pins also. There are analog pins also, depending upon the sensor that you have. Then you can control your sensors with these digital pinouts. ठीक है. Now the question is, these were simple sensors, ठीक है, having a numerical data set, जो कि temperature, कितना temperature है वो सब चीज़ें देते. For example, if I have a sensor like this, a camera, ठीक है, अब इसमें तो ये image है proper, data set high है. So या मेरे पास एक और sensor है, this is LiDAR sensor, light imaging detection and ranging sensor. If I have this sensor also, the data that comes out of these sensors is very huge. And when you process, when you talk about processing of these, you cannot process it in a control station and then come back and then take an action. When you do things real time, at that time you have to take data from these sensors real time, process it and take decision at the same place. And what you do, you cannot do these, with the help of these devices. Then, and maybe you want to do some sort of artificial intelligence also. You want to run some AI models also. It is not possible to run, AI model in this device or in this device also, because these, models are little bit, consuming more. They are more computationally intensive. So for that, you will use one more devices, more powerful. This is known as Jetson Nano. This is Jetson Nano. It also fits in my palm, and this is having more computational power than the Raspberry Pi, even more computational power than your laptop. You got my point? So then we can have, it's an edge device that you place. You don't go to the cloud, you execute everything on the spot only. Okay? So this is Jetson Nano. Then you have Jetson Orion also. Then you have many other devices also. So I have given you 3 generation of these devices. The first one was Arduino, simple device, and then there was a single board computer by the name of Raspberry Pi, and the third one was Jetson Nano. Okay? So these training programs are there. It's not possible in these 7 days. You'll be taught each and everything. Yeah, you'll be familiarized with each and everything. But our main aim is that you should get sensitized, and then when you get sensitized, when you hear the names, then you can go at your places at the back and you can check more and get more details about it and start using these devices also. बैठो साकिब, और है कुछ? LoRa, I will go to the LoRa. I will go to the LoRa next. हाँ ठीक है, अब LoRa पे हैं. Now let me go to the one more sophisticated smart network. ठीक है. So I'll try to show you that how this, we call it a wireless sensor network. ठीक है, कोई वायर नहीं होनी चाहिए, ऑटोमेटिक आपका डेटा ट्रांसफर होना चाहिए, रियल टाइम होना चाहिए और एफिशिएंटली होना चाहिए, लो पावर, लॉन्ग रेंज, एवरीथिंग. सो व्हाट विल डू इज दैट फर्स्ट ऑफ ऑल यू हैव दिस स्मार्ट सेंसर. ठीक है, जो ऊपर वो डायग्राम दी हुई है, दिस इज द डायग्राम ऑफ अ स्मार्ट सेंसर. सो इन दैट स्मार्ट सेंसर यू हैव व्हाट, सेंसर 1 2 आप देख रहे हो ऊपर, है ना, सेंसर 1 2. देन यू हैव अ माइक्रो कंट्रोलर, बिकॉज सेंसर अकेला काम नहीं कर सकता. ये आपका सेंसर क्या करेगा काम, जब तक कि आप इसको किसके साथ नहीं कनेक्ट करोगे, माइक्रो कंट्रोलर के साथ. यू विल कनेक्ट इट विद द माइक्रो कंट्रोलर. अब ये माइक्रो कंट्रोलर के साथ आपने इसको कनेक्ट किया, इट विल नॉट वर्क अंटिल एंड अनलेस इट हैज अ पावर सप्लाई, पावर सोर्स. ठीक है, एंड देन इट शुड हैव सम सॉर्ट ऑफ मेमोरी ऑल्सो. ठीक है, इट शुड हैव सम small amount of memory so that data gets stored in it. Can we take break for 2 minutes, 5 minutes? Can we take break for 5 minutes?